Okay, so in today's class, basically we are going to solve a question related to the capacitors. Okay, in the basically single supply operation, we discussed that we require some capacitors in place of VCC by 2. So yeah, so I just draw one circuit. Ground. Okay, so first of all, this type of questions. So we require these three capacitors, one on the positive terminal, one on the negative terminal, and one on the output. Okay, so the purpose of this capacitor to provide the voltage. Okay, the purpose of this capacitor is to provide the voltage. Like for example, if I am using a circuit, like for example, we are not taking this one. Okay, we are not taking this one. We are not taking this one. We are not taking this one. And our voltage is VDD by 2 and minus VDD by. Okay, VDD by 2 and minus VDD by. So it is a simple circuit. Vi positive, negative, grounded, V out. Okay, this one is the R1. I consider this is the R2. So what is the output voltage in this case? What is the output voltage? Just any idea what is the output voltage in this case? It is a simple non-inverting amplifier. Okay, Okay, if I connect a VI, it is a simple non-inverting amplifier. So output voltage is nothing but VI 1 plus R2 by R. Simple. Okay. Now, for example, we are not using the voltage here. We are connecting with the ground. We are using the voltage. Now, what is the V out? It is a negative terminal, non-inverting, inverting terminal voltage. So output is
minus Vi R2 by R1.
R2. Clear? So if this V out will be lies in the range of plus VDD by 2 to minus VDD by 2, no issue. Okay. Now the thing is that I just convert this to into the single supply operation. Single supply operation, for that one, what should I do? I just add a VDD by 2 in the supply and VDD by 2 in the supply. Okay, so the positive supply will be the VDD and negative supply is now ground. Now ground. Now the problem with the no inverting amplifier is the inverting amplifier will provide me the output in the negative. But now my supply range is what? VDD to 0. Okay. So this is the problem with the inverting amplifier. So what should I do? I have to add something in this one. So it will be also add the voltage plus VDD. So the combination of both will be boosted into the positive direction. If I improve my basically increase my supply in the positive direction, so I have to boost up my output voltage. So it will be either the positive or a less negative. So for that one, I just add a VDD value. Is it clear? Is it clear? Any doubt in this one? Now the thing is that if I apply a VDD by 2 voltage at a non-inverting terminal, so because of this one, we are getting output voltage is V naught. The changes in the output voltage is VDD by 2, 1 plus RF by. That means it is a VDD by 2 plus VDD by 2 times RF by. So we required only this term. But what we are getting along with this one, we are getting this term also. If I add my VDD by 2 voltage in a non-inverting term. Okay. Similarly, if I add my VDD by 2 voltage on a non-inverting terminal, so what should I get? V naught is equal to VDD by 2 minus sign with RF upon R or R2 upon R. Okay. So we are getting a minus VDD by 2 RF by. Now you can see this component and this component both are same. One in the positive, one in the negative. So if I add both voltages. That means if I add a VDD by 2 on a both terminals. Okay, so I add a VDD by 2 here. I had a VDD by 2 here. So my output voltage is nothing but, because of these two addition, these factor will be cancelled out. So only the output voltage that we are getting previously plus only the VDD by 2 terms. Okay, so we are getting a VDD by 2. We are getting the addition of VDD by 2. Now to remove this VDD by 2, what should I do? I just choose a capacitor in a opposite polarity. Okay, and the capacitor voltage is also the VDD by 2. So finally at the output we are getting a only, because both voltage will be cancel out, VDD by 2 and VDD by 2 cancel out, so remaining is the Vout. Is it clear? Now we are providing this VDD by 2 voltage, this VDD by 2 voltage, and this VDD by 2 voltage through the capacitor. So that's why we add a capacitor, capacitor, and capacitor. Clear? To charge this capacitor, what should I do? I just use the VDD supply. Okay, so I have a VDD supply. Okay, with the same VDD supply, I just connected to particularly equal resistance to apply the voltage divider biasing. So because of this VDD, the voltage drop across this resistor is what? VDD by 2. Okay, and that particularly voltage is used to charge this capacitor. We use the same capacitor here, the same capacitor here, so everywhere this particular capacitor will provide the VDD by 2. Okay, any doubt? Now the advantage of using the supply, this particularly single supply operation is, the advantage of single supply is only one supply VDD is required for whole circuit. Otherwise, if we are working on the dual supply, we require two supply, plus is the one VDD by 2 and second is the minus VDD by 2. So you have to create a two different circuit to create a two different supply. Okay, if we are using, if we are not using voltage divider biasing, then we require a two supply, one is the VDD and second is the VDD by. Okay, if we are not using this potential divider, okay, so we require this particularly point as a VDD by. So we have to connect a VDD by 2 volts. So again two supplies. Okay, again two supply. In the non-mathematically, we can say that we divide it by 2. But when we are going to generate a signal, a sinusoidal signal to the DC signal VDD by 2, we have to require a completely new circuit. Okay, we have to require a complete a new circuit. So our circuit should be complex. Okay, now the thing is that we are using a capacitor. Okay, if we are not using the capacitor, we require a battery. Require a battery. Okay, the problem is the battery is not a stable. Okay, why? Because we know that battery voltage will be reducing. Battery voltage is reducing. So after certain time, we are getting a different voltage. VDD in place of VDD by 2, we are getting a VDD by 3, then VDD by 4, then VDD by 5. As we time will be going on, the voltage will be continuously continuously. Now, if we are using a capacitor, so the capacitor and resistor combination create a RC filter. Okay, capacitor and resistor combination create a RC filter. So basically, that if we are creating a RC filter, so that particularly filter will pass certain frequency. Okay, will pass certain frequency, and that particularly frequency will be dependent on R. Okay, so choose a C. So chosen of C capacitor is also very important. Why it is important? It is important because of two reasons. One is the frequency selection, second for the time cost. Second for the time cost. Okay. So we have two different frequencies component, one for the input, one for the output. Okay, so if we are using capacitor here, like for example, if we are talking about this capacitor, so this RC circuit. Okay, and because of this RC circuit, the frequency of operation is F is equal to equal to 1 upon 2 pi RC. Similarly, for this particularly capacitor, again the frequency of operation is 1 upon 2 pi RC. But here you can see that R is not connected. Okay, no R is connected. If there is a RL is given, like this one is, if RL is given, so we are using the F is equal to 2 pi RX. Okay, here we can say it is a R1C because it is a R1 and R2. Okay, and this particularly frequency of operation F is equal to 1 upon 2 pi. Now these two are so parallel combination of R. So R parallel with R times C. Okay, so three different frequencies. Now, for example, if RL is not given, okay, if RL is not given, if RL, then the frequency of operation is similar to this one 1 upon 2 pi RC. Okay, we are taking the input signal frequency, both are same. This frequency and this frequency. This frequency and this frequency both are same. We assume that one. This is not exactly same, but we assume that one because of RL. We can't say that RL is not available, so RL value is zero. So if RL is zero, so the output frequency is infinite. Okay, so this is not possible. Okay, so what we assume, we are assuming that this frequency and this frequency is almost same. Is it clear? Any doubt? Yes, any doubt?
No, sir.
Okay, now assume that the frequency of operation is 1 kilohertz. Calculate V out, C1, C2 and C. Yes, what is the V out voltage? Does anyone what is the V out voltage?
Sir, I'm facing problem in this question.
Why? What is the problem you are facing?
Uh, I mean the capacitors over here. I mean how to deal with them.
Okay. So basically thing is that if we are using the three capacitor, so the output voltage is there is no effect of that one. Okay, because we already.
Sir, I can't hear you, sir. Your voice is very low.
Hello, am I audible now?
Yes, sir.
Okay, so basically we already saw that if we are using the three capacitors. Okay, so we are getting at this point what is the voltage? That voltage is nothing but the normal V out voltage plus VDD by. Okay, and after this capacitor we are getting only the V out, that is a simple gain. Okay, so if we have this circuit, so if we are remove, forget about this thing, forget about this capacitor and forget about this capacitor, your output voltage is nothing but Vi times 1 plus 50 divided by 5. Simple. Okay, so Vi times 11, so 11 Vi. Okay, if we are getting the voltage at this point Vx, so Vx is what? 11 Vi that we are getting plus VDD by 2. Okay, any doubt?
So, sir, instead of capacitors, we are assuming that it's VDD by 2.
Yeah, that's we are using only for the VDD by 2 in a single supply operation.
Okay, sir.
Okay, now this is the one part. Second part is we have to calculate the C1. So C1 is what? We know the formula F is equal to 1 upon 2 pi RC. Okay, so C1 is nothing but 1 upon 2 pi into R into F. Now what is R? Here you can see the R is the parallel combination of 10 and 10K. So if the capacitor will be discharged, so the particularly voltage current, basically the direct current will be distributed. So these two capacitors, these two resistors are in parallel. Okay. So 1 upon 2 pi. The parallel combination of R and R is R by 2. So that is 5K into the frequency of operation is 1K kilohertz. Okay, so C1 value is nothing but 1 upon 10 pi into 10 raised to power 6, or it is a 10 raised to power minus 6, 1 upon 10. So this is the zero point 0.3 into 10 raised to power minus 7 farad. Nearly about it. Okay. Now this capacitor will be create a combination with this resistor. So C2 is 1 upon 2 pi RF. Now what is R is 5. So
5.
1 upon 2 pi into 5 into 10 raised to power 3 into 1 into 10 raised to power 3, because F is always a 1 kilohertz. So same, that is zero point 0.3 into 10 raised to power minus 7. Now C naught 1 upon 2 pi RL time F, that is a 1 upon 2 pi into 10 raised to power, sorry, 20k, 20 into 10 raised to power into 1 into 10 raised to power 3 F. So this is the 1 upon 40 pi into 10 raised to power 6. So around 10 raised to power minus 6, 1 upon 40 pi. So that is 8, around 8 into 10 raised to power minus 9 farad, or 8. Yes, any doubt?
No, sir.
Okay, so in this way we can solve the capacitance problems.
Sir, it will be 8 nanofarad, right?
Sorry, 8 nanofarad. It will be 8 nanofarad. Okay. So I think we will wind up the session today. If you have any doubt, you can ask.
Sir, which book should we follow?
There are the lots of the books are available, so I will share it with you. Okay, one book is the Electronics Microreference System by the Sedra and Smith. Okay, so I will share some books with you in G Space.
Okay, sir. And sir, quiz one will be subjective,
Yeah,
right?
quiz one, quiz two, and Anthem all are the subjective.
Okay, sir.
That's why the assignments as well as the your handwritten solution is very important. Okay, so thank you all.
Thank you, sir.